So in the parent function, you're going to do this completely, okay? Once you do this, this is your main start, okay? After that, book a follow panna, it is very easy because you're going to go by function in the sense. So this is a test review. You can do it and compare with the real activity.
Yeah.
Make sense?
Yeah.
This is the start, okay? Once you get started with this, then you can go one by one, or see odd even functions. Once you do that parent activity, then you'll know all of this, even an odd function, then functions. So you will know all of this function inverses, factoring, whatever you studied in algebra 1 will be reviewed. Priya, then follow the book.
Mm.
Make sense?
Yeah.
Then absolute value function, unit 2, then unit 3 is quadratics. It goes in order. Make sense?
Yeah.
Okay. Maybe I'll work, meaning let me finish all the classes by May 22. I'll work with you and Manav. I want to check where he is and where you are. Make sense?
Okay.
Okay. Manav, you had some questions or your mom had some questions, right? I will definitely call your mom. Did you have any
Yeah,
questions for
I'm
me?
really confused. The book questions are really hard.
The book question, oh, really hard, huh?
Cause
This one?
like you gave some like homework parts that like I didn't really understand. I didn't
No
know
problem at all. Let's go over
I
it.
didn't
What is
know
the
if we like learned it or something.
Okay. Makes sense. So let me go over it. Pranav, what are you doing in school?
Huh?
Pranav, what are you doing in school?
We're just reviewing everything now.
Oh, okay. See, for the other class, I did finish everything, but yeah, in your class, there's a lot to go over. I know. Next week, we'll have a longer class, Amma. For me to finish things in logarithms, we'll have a longer class. Let's go over now. Today I was stuck with something else. Okay, what is your question, Manav? Page number, what are your questions? Tell me page.
Yeah, I'm just looking.
Huh?
Is it? Can you do page 788 part B?
788.
Part B.
Okay. 788 part B. Sure. 788, Amma. 88 part B. Okay. Okay, you're not able to plot this regression, huh?
No, I could get the regressions, but I couldn't get like I couldn't get the last part. I was confused.
Okay, use a graphing calculator to find a regression model for the data and graph the model with a scatter plot. What does the model compare? How does the model compare to the previous model? So basically, you're given a set of table and values, right, Manav?
Yeah.
Okay. Now, wait. How did you get this? So you found the equation, right? First, you found the equation of this, right? Meaning a b power of x, you started with the a value and then b power of 8, okay, and you chose 7.50 and 2009 for that matter. So you got your equation a b power of x, correct?
Yeah, my equation for A was 15,300 times 1.062x. Like to the power of x.
What is that? Come again?
Oh, wait, are you talking about part A or part B?
No. I am coming from part A to part B.
Yeah, I used the table. I used 15,300 as the as x equals 0.
Correct.
Then
F-
so I put that was x equals 0, and then I put that in the calculator, and I got in exponential regression. It showed the equation was 15,300 times 1.062x.
Amma, you are on page number 780?
8.
Oh, 88.
It's one about cars.
Okay, so, okay, wait. Let's go over. Let's go over. Pranav, when is your exam, Pranav? Final exam?
I think it's next Thursday.
Next Thursday. Okay. Let me share my screen. Let's go over this. I know in this class we are a little slow, but let's see. Share. Okay, so here, what is your question? I was looking at the next one. Okay, so you have a table. The data gives the estimated value in dollars of the model classic car over several years. Okay, that makes sense. Find an approximate exponential model. So first one, how did you find it?
I put the table in the calculator, and then I asked it to give me the regression model.
Ah, that is for B, correct?
Is it not for A?
Oh, wait. Are you calculating the regression? Find an approximate exponential model for the car's value.
I thought we're starting
They
from
did not
A.
do it. They did not using that, right? Meaning, A, they just found with the two value. See, okay. See, one thing is you can type in the table and go for exponential regression in the calculator and find the regression model. Okay. The first one, when you think about it, what did they do? 0, 15.3 was a value, correct?
Yeah.
The model is y equal to a b power of x, correct?
Yeah.
So basically they took the 0, 15.3. So 15.3, they took it as a. Does that make sense?
Yeah.
And then they calculated b. X comma y is any value in the table. Does that make sense? X comma y is any value in the table.
So I didn't have to do the regression.
See, this is not regression, right? You can substitute. Wait, let's see. Over several years they have given. So I will take it as 0, 1, 2, 3. You can see there are many values in the table, right? One is, wait, 0, 15 point. Why did they take 15.3? 1 second, wait. 15,300. Okay. 15,300 in thousands of dollars. Okay. 4,300. Okay. It should have been, see, there's a typo in there, I feel. It should have been 15.4, right? It should have been 15.4, right?
15.4.
Yeah, because how 0, 15.3, where did they get it from?
I think that was starting.
Yeah, starting is 15, 4300, right?
No,
Oh, you're not seeing that?
no.
What is the first value? What is the first table value?
It was 0, 15,300.
Second one?
1, 16,100.
Oh, for me it's different. See, 1, 16,000,
100.
103,
18,400.
oh, my values are different. Okay, then what is the other one?
I think you skipped the second one.
Okay, tell me, what is that? 2,
The second one is 17,300.
yeah, 17,300 I do see. Okay, this and this are incorrect for me. Okay, so 4, 19,600, correct?
Yeah.
Okay, so with this in place, right, they just substituted that in here. And if you think about x and y, you can have any value from here. You can have 3, 18,400 or 4, 19,600. You can substitute x, y as, you can either do 3, 18,400 or you can put 4, 19,600. You can take any value from this table, substitute and find out the b, and then write the equation for a b power of x. You will know a and b, and then x and y can be unknown variables. Correct, Mana?
Yeah.
So this is not a regression model. Regression model is you'll put it in the calculate. You'll put it in the calculate. See, this is the model. This is the exponential model you are trying to find out from the table of values. Make sense?
Yeah.
The other one is in the calculator, you can put a regression model as well. Makes sense. When you type it in the calculator, it will slightly differ, but doesn't matter.
But would a regression model still be correct?
Then, yeah, they will be they both will be very similar. Does that make sense?
Yeah. Wait, do you have the answer for B? The B
Okay,
part?
answer. Let's see. In the last year of data, a car enthusiast spends 15,100.
No, like B in this equation. I got 1.062. I'm not sure.
Correct. That is correct. Why? That is correct. So your this is 1.062 power x, right? That's all. This is your exponential model. What is your question in this?
Oh no, I don't have a question there.
You got it perfectly. B is your question, huh?
Yeah.
Okay, B says, what does it say? See, use your model to create a table of values with a graphing calculator. How long does the function model predict the owner should keep the car before he can sell it, before it can be sold for a profit of at least 5,000 they're asking. Okay, so let's see. See, last year a car enthusiast spends 15,100 on a car of a given model that is in need of some work. The owner then spends 8,300. So he's already spending how much? 23,400 he's spending, correct? To make a profit, he has to sell it. See, basically 15,100 he's spending on the car plus 8,300 he spent to restore it, right? So basically the cost price of the car went up to 23,400, right? For him to make a profit of at least 5,000, he should spend it at 28,400. Make sense? Make sense?
Yeah.
So you know what you need to do? You will put these values in the calculator, right? You will have to see a y value where it becomes greater than 28,400. Does that sound good?
And then you would just write the equation for that.
You don't need to write the equation. They are just asking how long does the function model predict
Oh,
the
so you just find the y value for the.
you just find the x value, right? X is the years, number of years. You get it?
Yeah, I get it.
Okay. Yeah. Now you got it.
Yeah, I get that one.
Okay. Any other questions? Anybody?
I have a question. I have another question.
Okay. Go ahead. Pranav, did you have any questions from your school?
No.
Okay. Go ahead. Go ahead, Manav.
Could we do number 9 on 789? It's the next page.
789, number 9, huh?
And part C, the last part. It's on the last page. Next page.
Oh, okay. Yeah, we can do. Okay, guys, I'll give everybody an intro. Okay, otherwise nobody will understand what we are doing. So page number 789. Okay, number 9. So there is a table. There is a table that tells the average price of a movie ticket in the United States from 2001 to 2010. Okay. So now it started at 5.66. It went to 7.89. Okay. So basically, you have year and the price of the movie ticket. I'm not going to draw everything. Okay. So now make a scatter plot, use the first point. See, they have clearly given use the first point and another point on the plot to find the approximate exponential model. That is what you do for y equal to a b power of x. First, you need to substitute a, then find out b by substituting any value of x and y. So you get the model as y will be equal to 5.66 times 1.036 power x. Does it make sense till here, Manav?
I got 8.
Okay, that's okay. 1.038.
I'm not sure. I got 8, I think.
Okay, doesn't matter. Should be fine. Okay, you might have chosen one value. They might have chosen one value. That will be the difference. Okay. Now using graphing calculator to you find a regression model. How you will find the regression model? That is different. This is the approximate exponential model you will get based on any one value in the table. Okay. What you get in the calculator is your regression model, in the sense you will type all the table values and then they will try to make an exponential line using all the data points. Okay, so that regression model says it is equal to 5.59 times 1.037 power x. They'll be very, very similar though. Okay, now what is your question? Your question is C, huh?
Yeah, it's correct.
So they're asking in the regression model, what will be the prediction for the year 2014? They're asking, correct?
Yeah.
Okay. How does this compare actual 2000? See, when you use this model for the 2014 year, the cost of the movie ticket, works out to be 8.35. Okay. A theater owner uses the model in 2010 to project the income for 2014, assuming average sales of 490 tickets per day at the predicted price. If the actual price is instead 8.35, did the owner make a good business decision? He's asking. Okay, you are not able to answer this, is it? Okay, so when you look at this from 2001 to 2014, right? How many years passed by? 2001 to 2014. So 13 years, correct? Manav, are you with me?
Miss Priya, could you check my
Yeah.
message real quick?
Manav?
Yeah. I'm here.
Something is not. Are you with me?
Yeah.
Okay. So there are 15 years here. I'm frustrated about this.
Miss Priya,
Yeah,
could you check my message real quick?
you want. Yes, please go ahead. You
Okay,
can
thank
just
you.
put a message, but have your video on, right? Otherwise,
Okay, yeah, I'll
Okay,
do that when
thank
I come
you.
back. Thank you.
Okay. Now, with all this, see, from 2001 to 2014, 2014 year is our is the year that we are going to discuss what is going to happen. So between 2001 and 2013, how many years are there?
12.
Ma, 2001 to 2014. So you consider
13.
13. So 13th year is what you need to find. This is one. This is the first one, right? This is the 13th year, right? Then, this is the 0th year. I'm sorry.
Yeah. And then,
0th year, and so this would be the 13th year. So now what you would do, this would be 13. Am I making sense?
yeah.
The number of year would be 13. So when you substitute that, right, the y value for the 13th year would be, when you substitute this as 13, whatever you get, let's say you get approximately, okay, 8.96 you will get. Okay, 13th year, a movie ticket would be selling at 8.36. Okay, now they are 8.96. Okay, now they are saying, right, what did they say? They are saying actual 2004 cost was 8.35. This is just a model. This is used for only prediction. Okay, based on this model, you are predicting that in 2014, the ticket will sell at 8.96.
Wait, Miss Priya, did you put 13 in the 5.66 or the 5.59 equation?
Okay. I put it, this is the regression model, ma. I did not even touch this. Okay, read the question. The question literally is asking, see, okay. What does the regression model predict for the average cost in, okay. You have to put it in the regression model. That's the question. That's what the question says. So put that 13 in here. The question is read. How does the regression model predict the average cost in 2014? How does this compare with the actual cost of 8.35? Okay, I read it incorrectly. So did you put 13 here? What did you get, Manav?
I'll check.
This is the approximate exponential model you are finding from one of the points. Okay, this will be approximately correct, but this is the regression model you can rely on. Okay, they
Yeah, I
will
got
tell you where
8.96.
you need to substitute. Tell me.
I got 8.96 in the regression model.
8.96. See, regression model, when you put, you get 8.96. Okay, but they mentioned in the question that actually the ticket was selling at 8.35. You got it?
Yeah.
So he predicted his movie theater will generate per ticket income as 8.96. But actually, the business owner only got 8.35 per ticket. Did you understand?
Yeah.
So automatically the revenue will fall short, right? Meaning this much of difference per ticket is falling short. So he's going to be at a loss, right?
Yeah.
Am I making sense?
Yeah, makes sense.
So for 490 tickets, what will be the revenue? 490 tickets per day. They are saying he's selling 490 tickets, right? 365 days, 490 tickets. So you're falling short by how many? 8.96 minus 8.35, right? So that is 0.61, right? 0.61, no? Yeah, 0.61, right? So if you fall short to that level, this is going to be this much of this much of dollars he's going to lose, right? Does that make sense?
Yeah. Do we have to find the part that we have to find? Do we have to equate that?
There's no equation, right? Ma, the question is asking how he be running on a profit or a loss.
Oh.
Okay, so he will definitely be running on a loss because per the prediction, when he bought the movie theater, he would have thought in 2014 the ticket will sell at 8.96. But actually, the ticket is only selling at 8.35. Okay, his prediction is he's going to, his actually, there are 490 tickets that are getting sold every single day of the year. Okay, 365 days, 490 tickets. Each ticket is costing, he is at a loss of 0.61 cents for each ticket. So this much money he's going to lose. You got it?
Yeah, I got it.
That's all. Can I move on now?
I have one more. I have some more
Manav,
questions.
I'm going to put you to a stop and I'm going to go to quadratic functions. Okay.
Okay.
Let's move on to, I'm sorry, let's move on to logarithmic function. Did we discuss log functions last week? Did we discuss log functions? Ishruti, you can say, right?
Oh, I actually didn't finish the video.
Okay.
I only
Great.
saw like 40 minutes in or something.
Okay. Manav, what was that we covered last week? I want to check, guys, now once.
Yeah, you taught us how to like change exponential to logarithmic.
Logarithmic, 821 to 37 I've given. Okay, great. 21 to 37. See, here we are lagging. 21 to 37. I did not plot. Okay, let's see this one. Did we discuss logarithmic properties?
No, we didn't.
We did it. Oh, yeah. Yeah. I got it. I got what I did. Okay. Okay. Okay, then we'll check out logarithmic function graphing first. Or I can go to properties and then go to graphing. Okay, graphing we'll keep it last. Okay, properties are easier. So let me finish the properties and come back here. Okay, logarithmic properties module is the 16th module. Okay, properties of logarithm. So I'm going to go there, then later come back to this. Okay, let's see. How about this? Okay, how about this? Regarding the properties of logarithms, properties of logs. Okay. We do have, just like exponential properties, we do have some basic properties. Okay, by the definition of logs, definition-based properties we have. One is log b base b. When the number and the base, they both are the same, then this is entirely equal to just the exponent. Number one. Number two, log 1. Log 1 in any base is equal to 0. Okay, log b base b is always equal to 1. This and this are very similar, meaning when the base and the number for which the logarithm is taken, right, when both are the same, it's just equal to 1. Okay, here when the number and the base is the same and you have a power, that becomes your value. Now, product property of logarithms. What is this product property? Shri, are you back? Okay, product property
Yeah,
of
I
logarithms.
just got back.
Okay, I want the video on. Okay, log base b, when you have two numbers together, I can expand it like this. Number one. Okay, then quotient property. See, this is very similar to exponent properties. Okay, log base b, m by n. This is division. When you look at it, log m base b minus log n base b. Okay, it's similar to exponent properties. Okay, and then power property. Same things we have here as well. Power property, what does it say? Log base b m power n. This n, right, the power can be put at the back. So it becomes n log m base b. The last one, change of base. This is quite important, guys. You might want to change bases often in logarithms. I will deal with examples for this. Okay. Now, if there is a given function log a base c, I want to convert it to log b. Let's say I want to convert it to a log function with base b. So basically, I'm changing base c to base b. What will I do? Log base b. First, I'll convert this number to my required base. This is the base that I need. Okay, divided by log c base b. See, I'm converting this function from logarithm base c to logarithm base b. I'm converting to a different base. So what I need to do? Log of that required base a and then log c, this base, log c in that required base. This is very important, guys. I'll give you examples. You have made a note of this? These three properties are very easy. It's like exponent properties. Okay. This one is interesting to reduce or simplify several logarithmic functions. These two. Can I move on? Okay. Now let's try this one. How about this? What is this? What is the value of this? You tell me. What is the value of this entire function?
X plus y.
Yep, that's it. It's equal to x plus y. So when you use the properties, this becomes very easy. Okay. How about if I have log b mn? How can I expand and write? See, if you go from here to here, it's expansion.
You can do log b times m.
We read it like this, ma. Log m base b.
Log
Plus-
n base b plus log n base b.
Correct. So this is expansion. If you come into the reverse order, it is condensing log functions. Okay, can I move on? So let's see some of the examples. How about this? Log base 3.
Brianti, can you like go back to the last part, please?
Sorry.
Okay. Thank you.
Can I move on?
Yeah.
Okay. Now, let's say you're given this, okay? Meaning, just remember the properties, guys. Just like exponents, you have product property, quotient property, okay? Power property. Power property means you can put the exponent to the back here. That's all, okay? Other than that, log b base b will always be equal to 1. Here, what happens is, if you have a power, right? You remember the power property. This can be written like m log b base b. Okay, so basically this is 1. So as a result, this will be equal to m. Okay, these are the important properties to remember. Now let's say log base 3 of log 81 base 3. How will you do this? Anybody? Pranav, you can tell me, right? Go ahead and tell me, Pranav.
Which one?
Go ahead and tell me how to simplify this. I want to simplify this. Simplify this means bringing up one number for this one.
Isn't it just like -1?
Oh, wow. How did you get it?
Because 27 is 3 cubed.
Yeah. See,
And
this
then,
one, try to express it as the base. Nice. This is 3 cube. The power goes to the back in a log. 3 log 3 base 3. So this becomes 1 minus log 3 power of 3, 3 is a 9, power 4, right? 4 goes to the back. So this one is a 1. Again, this one is as well as a 1. So 3 minus 4 is a minus 1. Make sense? See, actually, using properties of logarithms, once you understand the properties, the problems are so easy. Now, let's see this one. Log 64 cube base 4. Can you simplify this quick? This one. Yeah, this one you can simplify. 4 4s are 16, 16, 3. Yeah, why don't you simplify that quickly? 4 power of 3. Yeah, can you simplify that? You don't need calculators at all. It's very easy. It's a number, but you have to use the properties. I know that you are introduced only today, so you can try. If you don't know, you can ask. Manav, would you mind if you have more questions, right? I'm absolutely open to help you. Can we do I have a class. So would you mind logging in after the class? Are you available?
Wait, today?
Today.
Do you know what time that is? Is that 8 o'clock?
It is at your time, your time 8 o'clock. Would you mind coming? No, if you're busy, we can set up some other time. I'll clarify all your questions. You're going to write CBE, right? Hey, go ahead and do, guys. Shruti, that's not correct. Pranav, correct.
Yeah, I can do today.
You can do today. Okay. Just log in, okay, without fail. So here, guys, I'm going to do this for you. See, this one, right? Try to match it with that. That's the secret. So 4 4s are 16, 3, 4 cube, right? First of all, put it to the back. Okay. Now this you have 64 here, right? Again, log base 4, 4 power of 3. Okay. Now what happens? 3, 4 cube. Again, it comes to the back. 3 times 3. 9 log 4 base 4. So that is 9. Make sense? Shruti, where did you miss, Shruti?
Why can't you make it 2 to the power of 2?
You can, but what is the use? Because if it becomes 2 to the power of 2, you cannot cancel this to 1, right? Because it's not the same as the base. Am I making sense?
Yeah.
You can, meaning it's valid. For that matter, instead of writing 9, you can write it like this. I agree. But then this is not simplified than this. Am I making sense?
Yeah.
Yeah. So this is completely different. You can just cope up with the log functions with whatever we are dealing with here itself. Let's see this one. I really want you to do this one, guys. Let's see. How about this? Log 798 log 2 base 7 power x. Oh, what I'm writing. Sorry. Log 98 base 7 minus log 2 base 7 power x. Can we try that? You want to try or you want me to try? Please let me know, guys.
Miss Priya,
Yeah, Yukti.
would we have to do change of base for this?
Would you have to change your base first? No, don't change the base unless it is really required, right? But here, yes, I am thinking, but let's see. First, did you solve this one?
No, I was talking about that I had to like change base, so I was a bit confused what to do there.
You definitely have to change base is what I'm thinking. Okay, let me go ahead and do for you. Log base 7, 97 by 2, right, Ma? I'm sorry, 98 by 2, right, Ma? 98 by 2 is 49, right? Yukti. Did you do
Oh,
it?
so you can just divide?
No, yeah, this one you can divide. This is just a number, right?
Okay.
Yeah.
Oh, I
So,
see.
so no, so let's see. See, log base 7, 49. 49 is something similar to 7. Do you see it? So what I can do here, 7 square I can do, right? So that way, why do I do that? I do that to make this a 1. Am I making sense? This will come to the back. The power
Yeah.
will come to the back. So that will become log 2. Basically 2, but a log is outside. You get it? Did you
Yeah.
get it? Okay, after this, what happens? So this becomes x log 2. Okay, if you're allowed to use a calculator, you have to find what is x log 2 and write out your answer. If you're not allowed to use a calculator, you can just write x log 2.
Auntie, I'm kind of confused on how you just like divided the 98 by 2.
Okay, see this, okay, whatever is inside here, right? Let's say 64 by 4. This is just a fraction. This is a number.
Mhm.
You got it?
Yeah, but wouldn't just like, because you have a 98 right now, like in the original equation or like expression. So if you divided that by 2, like just like that, then wouldn't it change it?
This one,
Yeah. How do
division,
you just like divide the 98 by 2? I don't
because
understand.
this is subtraction, right? There is a property, quotient property. Remember, here log base b m by n, okay, will be equal to log m base b minus log n base b. Make sense?
Oh yeah, I see.
That property I'm using it to condense this, meaning I'm coming on the reverse.
Yeah, I see. I understand now.
Okay. Can I move on?
Yeah.
So that's what I'm saying, meaning both ways you will be using. One is condensing, one is expanding. Make sense? Does it make sense?
Yes.
Okay. Now let me see, how about this? We'll do one more, we'll do one or two more problems, I feel. How about this? Okay. The difference between apparent magnitude M, this is apparent magnitude. Let me write it out, guys. Apparent magnitude, absolute magnitude. You have to do more problems, okay? We just touched, so I'll get you for homework anyway. Apparent magnitude is M, absolute magnitude is M of a star, okay? The formula, they'll give you usually this, okay? Here, M and M, I have said what it is. D is the distance of the star from Earth. Okay, you can use your calculator. You don't have to use your calculators at all. Okay, now they're asking, find the distance. Find the distance of a star. Please, you try, okay? Find the distance of a star with apparent magnitude. Apparent, please substitute properly. Apparent magnitude equal to 5 and absolute magnitude. The word problems, the book is really, several are really good. Okay, can you find the distance of the star? Did you get it? So D is measured in parsecs. The unit is parsecs. Did you get the answer? You have to use a calculator for sure. I want to see how you did. Did you change the log? Exponent to log is what I'm curious about. Can I do? Shri, did you do?
I'm doing it.
Oh, Pranav, correct. Pranav, it's easy for you now, right, Pranav?
Yeah.
I know. See, Pranav, for you, you should have come in the Friday, the Sunday class.
I'm
It's
confused.
okay. I know you can't.
I'm confused.
You're confused. Okay, so there's a formula given, right? What is this? Apparent magnitude. Apparent magnitude is small m. Substitute 5 in here. This is 0.4, right? So basically minus 0.4. I'm just plugging in values. These equations are just plugging in. Equal to 5 log d by 10, correct? So now I'm going to solve that here. 5 plus 0.4 equal to 5 log d by 10. Now, in this case, 5.4 equal to 5 log d by 10. Okay. Now, 5.4 by 5 equal to log d by 10. Any questions still here? Any questions still here? Any questions?
No.
Okay. Now, with this in place, see, I don't know if I mentioned it in this class. Log base 10 is implicit when there is no base given. Okay. Log base e can sometimes be written as ln. This is called the natural log. These are different functions. I'll tell you how. Now, what else? Any other base, you can have it like log base 4, log base 3. They're all different functions. Okay. But what is this log base 10, log base e? Why am I so confused? Okay. How? Let's see. Let's say I have a function log base, log, let's say log, okay, something I have log, let's say like this. Okay, log 2 base 10. Okay, this is a logarithmic function. If you convert to exponential function, this becomes 10 power of y equal to 2. The base always remains the same in a log and an exponent function. The base is always the same. I think we went over this last week. So the base is always the same in an exponent function and a logarithmic function. You see it here? So how do you convert this? Suppose if you have, so basically if you have log base 10, it's an exponential function with a 10 base. Then suppose if you have log base e function, what is that exponential function?
Oh, I
Whatever.
think I get it now.
So log base 10 function is a 10 power exponential function. Log base e function is an e power of x function. Does it make sense? Similarly, log base 4 function will be 4 power of x in an exponential function. So that's the difference. So basically, when you think about an exponential function, right, 2 power of x will be like this, 2 times 2 times 2 times 2. 10 times 10 times 10 times 10 will be the same like that, but it will be steeper. Log base e is what? 2.7 power. So it will be in between. Make sense, guys? This is for exponential function. See, this is for 2 power of x, I said. This is e power of x, I said. This is 10 power of x, I said. So now when you, suppose if you do, you are going to find the inverse, right? Exponents and logarithms are inverse, right? So what happens if you find out the inverse here? Let's see what happens. You'll have something like this. So all your functions will be either more steeper or less steep. So similarly, every exponential function has its corresponding inverse function, which is a logarithmic function. Am I making sense? Okay, now let's come back to our equation. 5.4 by 5, somebody needs to find out and tell me 1.08, I think, will be equal to log base 10 d by 10. Now, how to do this? 10 power 1.08, right? Or what is it? I don't know. Can one of you tell me what is 5.4 by 5? Can one of you tell me what is 1.4 5.4 by 5? Quick, come on.
1.08.
1.0.
1.08. Oh, good. Okay, 1.08 will be log d by 10, correct? Now, when you think about this, right? This is log d minus log 10. Am I making sense? See, equal to log expansion, log d base 10. No base is mentioned, no base is there, so it is 10 minus log 10 base 10. Now, you tell me, guys, what we can do. You know better. What property we can use? This will become a number, right? What number is that?
1.
1. Base is same, number is same. 1. So that minus 1 comes this side. This is 2.08 log d base 10. Converted to an exponential function, 10 power of 2.08 is equal to d. That's it. You got it? So 10 power of 2.08 parsecs. You will have to use a calculator for that, guys. Did I make sense?
Wait, Miss Priya?
Yeah.
I was still a bit confused how you went from 1.0 to 2.08. Is it because you did the log 10 base 10?
Yeah, ma, see, log b base b is always 1. Okay, I have log 10 base 10. So what will
Oh, okay.
this becomes 1. The minus 1, when it goes to the other side, becomes 2.08. Make sense?
Okay, yeah, that makes sense.
Okay, can I move on?
Yeah.
Okay, how about these questions? You will have to work it out and see, guys, a lot of it. Okay, let's see one more. Maybe I'll come back a little bit. Let's see this one. I'll come back a little bit. Okay, I'm not going farther. Okay, how about this? I'm coming back. I'm pulling you back a little bit. Let's see. Hey, Akash, are you following Akash?
Yeah.
Nice. Okay, go ahead. So what should be the answer for this one? Hey, grade 7 kids, please be patient with me today. Okay, I'll take another 5 to 7 minutes. Okay, you can switch off videos. You can switch off videos, but please come back in 5 to 7 minutes with the video on. Go ahead. I really want you guys to get the properties of logarithms and 1 or 2 word problems very nicely, because that concludes the whole module. Okay, but graphing I'll teach you next week. Did you get it? What is the answer? See that 256, as soon as I see, I feel like putting it in terms of 4.
Is the squared for the entire log 256 base 4?
Yeah, see the function is this log 5 base 5 power 5 plus 1 plus log 256 base 4. Log 256 square base 4.
Oh, it's 256 squared?
Yeah, 256
Oh,
squared.
okay.
That too, you can bring it outside.
I sent my answer, but I don't know if it's right.
Doesn't matter, ma, just send it.
You can only add the log if the base is the same, right?
Correct. The base has to be the same for you to get that added. Here, Anna, see, Akash, one thing what I'm seeing is you will get 1 in both, isn't it? 5 plus x, ma. See, I wrote it down incorrectly. See here, 5 x plus 1. Here, I wrote it down incorrectly. Right. See, if you understand the base, right, you can develop on it. Correct, Shruti Yukti. You guys got it, right? So the base, if you get it, come what may, a harder problem you'll yourself try. Okay, I know. Meaning towards the end, I'm not covering a lot of problems on the same category. I'm just moving on with your class. In the other class, we completed both. Okay, the next 2 classes, they are going to revise. But that's okay. Please understand, it's completely different, the 2 classes. I'm just telling you. Go ahead. Did you get it? Did you get it, all of you? Mano, correct. Shri, did you get it? 7th grade kids, please bear with me for another few minutes. Done?
Yeah.
What is the answer, Shri? What is the answer?
1 second. Something went wrong.
Okay, for the others, right, you don't have to wait, right? I'll give you one more. See small edges. Okay, we'll go to a word problem now. Okay, we go back and forth. Okay. Next week, please remind me, we will solve logarithmic graphing. Okay. And then connecting exponential and log functions, a lot more problems. Okay. With that, we'll conclude. Now, let's see this one. Please, Sri, you have to send the answer. I'm going to give the others another problem. So how about this? M will be equal to 2 by 3 log. Let me describe the problem for you. Going on. E. Wait a second, I don't know what is going on. Okay. So here we go. 2 by 3 log E divided by 10. Don't get bogged down by big numbers. You know how to do each of this, okay? Now, this is related to earthquakes, okay? E will be the energy released. E will be the, with this we'll conclude, okay? E will be the energy released. M is the magnitude of the quake. E is the energy released. You know, I want to understand, there was an earthquake that measured 9.2 on Richter scale. Richter scale is what they use to measure earthquakes, okay? We measured 9.2 on the Richter scale for an earthquake. Could you find out what was the energy released? It is just plugging in, but even if it is plugging in, it has got a lot to do with solving the log equation that's given, putting it, condensing or expanding, whatever. So now you have to find E. Did you get it, Shri, for the previous problem? Yes, you got it, Shri. Okay. Let's move on to the next one. This is a word problem. So with this, we'll conclude. Let's see. Shall I do? Shall I do or you want to do?
Wait, Miss Priya.
Hmm.
Just a question. So for the 10,
Power of 11.8, you can use a calculator.
yeah, but are we supposed to multiply that with the M? Like just take it to that side or?
Okay. So here is again solving another log problem. Let me see. 2 by 3 log E divided by 10 power of 11.8. Correct. So it's a little tricky. See, this is a number. Basically, this is a number. Log of that number. So can you expand it? What is that you'll use to expand it? You tell me. There's a division property of logs, right?
Yeah.
What does it say? Log E minus log 10 power 11.8. Am I making sense?
Oh, okay. So you would just like distribute it basically.
Yep. Pranav, you can get the answer now, right, Pranav, by this time? So
Yeah.
here you see implicit base is 10. Do you see it? So what happens here? What does this big number become?
It turns into 1. Oh wait, no, it would turn into 11.8.
11.8, correct. So log E minus
I have a
11.
question.
Yeah.
So log 10 base 10 is 1, right?
Yeah, correct.
And then to the
Anything
power of
like
11.8, isn't it still 1?
hold on. Good question, Akash. Okay, remember this property log b base b power m equal to m. You know why? I'll tell you why. Because first you need to apply b power of m, log base 10 this is, okay. Here, when you think about it, the m can be put back. M is put back, so it becomes log b base 10, okay. Now, when the bases are the same, first you need to put back. You get it? Very nice question, Akash. Did you understand why?
Yeah, it's just you have to do it first.
Yeah, meaning it's like PEMDAS.
Yeah.
Okay. Now here 9.2 times 3 divided by 2 equal to log E minus 11.8. 9.2 times 3 divided by 2 plus 11.8 equal to log E. But what is this log E? Meaning if you get the answer for this, do I have the answer? I don't know. Let's see. Yes, I have 25.6. 25.6 equal to log E. Log E means implicitly it's a 10. 10 power of 25.6 equal to E. Make sense? Does it make sense?
And since like
Why is there always automatically like a base 10? Is that just like that's like the normal number system, right? So if
Yeah.
there's nothing there, it's just like
Base 10, yeah, yeah. Why
Yeah,
is it
okay.
always implicitly a square root? Why
Yeah.
is it implicitly a square root? It's like that. Whenever I write log, our decimals, it's only 10 digits. So
Yeah.
it's more of that is implicit.
Okay.
But don't ask me why if I put it like this, it's not 10th root. You see, that's square root, right? So we have some what to say, conventions that we follow, right? Yeah. So this is square root like that. Log means it's log base 10.
wait,
Okay.
so since we can't simplify 10 to 25.6 because on the calculator it has like the ending with E, do we just leave it like that?
No, you'll have to have a proper answer. Okay. It will be around 3.98 power 10 power of 25. Did you have the answer starting with 3.98?
Yeah.
Yeah. So you have to write it out as 3.98 times 10 power of 25. Make sense?
Yeah, I get it.
Okay, I'll stop here, guys. Mano, but please log in one hour after if you have questions, and Akash, if you have something, you log in.
Okay.
Okay.
Okay, guys.
Wait, what is it? What is that class?
No class, Akash, but
It's
Mano is
after
going to ask
info.
some questions.
It's after
Okay.
Or just for just private?
Yeah, and yeah, I just want to clarify all his doubts.
Okay.
Okay, he's going to appear for CBI, cannot abandon, right?
Yeah.
So yeah, meaning you are not bound to log in. Okay, but I really want to give you some inputs as well. If possible, you log in.
Okay. Bye.
If you're going to prepare. Otherwise,
Yeah.
don't log in.
I am.
No.